Good evening, everybody. If we can all just be seated, and then we'll get started. Great, thank you. Welcome, everybody, to the Summer Space Series hosted by the Andy Thomas Foundation and Adelaide University. My name is Mark Slade. I work for Nova Systems. I'm the Managing Director there for the Integrated Solutions Business Unit. For those that don't know about Nova, privately owned, Australia's largest privately owned defence and security company, headquartered here in Adelaide, but with offices all around the world, or anyway, in New Zealand, Asia and the UK, so we call that almost all around the world. And our goal is to be a global systems innovator with a real focus on technology-led engineering services, systems integration and product development. So that's a little bit about me, but I'm going to hand over to Mark Charnley, who's going to do our acknowledgement to country.
Thank you, Mark. So as mentioned, my name is Mark Charnley. I'm the Director of Learning Futures for Adelaide University, and on behalf of the university, I'm delighted to welcome you all to the second panel session of the Summer Space Series delivered in partnership with the Andy Thomas Space Foundation. Before we begin, I'd like to acknowledge the Kaurna, Bowen-Dyke and Bangalara First Nations peoples and their elders past and present, as well as the traditional owners of the lands on which our campuses are located across South Australia. We pay our respects to the enduring connection to the land, sky and knowledge. This series certainly reflects Adelaide University's role in South Australia's space ecosystem and brings together education, research and industry to build capacity, skills and pathways that support the growth of space and space sector across the state. And I would like to thank the Andy Thomas Space Foundation and our amazing panellists that will be supporting the session this evening. So I very much look forward to learning more about Australia's growing footprint in lunar exploration, and in many ways our nation is contributing to humanity's return to the moon. So thanks, Mark.
Thanks. Have you got my... Thank you, Mark. Now I'd just like to introduce Darcy Watson, CEO of the Andy Thomas Foundation, just to do a small intro.
Thank you so much, Mark, and thank you to every single person in this room. We are so pleased to have you here and to see what you're individually contributing to Australia's growing space ecosystem. I also want to take a moment to just very quickly thank everyone who's joining us online as well. This session, we're actually joined by individuals from every single state and territory across Australia, as well as 9 countries across the globe. So just very quickly, a shout out to Alaska, New Zealand, China, Mexico, Nepal, Sri Lanka, Turkey, Estonia and the United Kingdom. And I think it's really important to just take note of those other nations who are not only interested but passionate enough to get up in the middle of the night to actually hear about Australia's growing ecosystem for space. So I think that's very important to recognise. The Andy Thomas Space Foundation, in collaboration with the Adelaide University, are very proud to bring this series together. Outreach is one of our 3 pillars, where we're very proud to try and make space a dinner table conversation across Australia, and each one of you are making that one step closer for us. We're also passionate about education, so making sure all of our students across the nation have access to space and STEM resources and an education growing up, as well as our industry engagement. So for those of you who are going on the tour tonight, you'll see some wonderful capabilities and you'll get to hear from some of our speakers about them tonight as well. But we're really proud to be partnering with so many incredible organisations to make activities like this possible. A huge thank you to our incredible speakers. I know you don't want to hear any more from me, so I'll pass it back to Mark so we can get this session started. But just a massive thank you from the Andy Thomas Space Foundation.
Thank you, Darcy, and thank you, Mark. I'd just like to take a brief moment just to acknowledge our co-founder of Nova Systems, who's sitting down the front here, Mr. Peter Nikoloff, who's here tonight. I know Pete's had a lot of involvement in putting all this together and is a very big sort of player in this space. I know apparently his house is full of space junk or something, that's what I've been told. Yeah, a big thank you to Pete and the team that's put this session together tonight. I'm really looking forward to it. I personally am not a space person, so don't ask me any questions about space. I'm hoping to learn a lot tonight about space, and I'm hoping that you'll take something away from the evening as well. I'd like to thank you all for coming. We're going to do a deep dive tonight into what we call Australia's growing footprint in lunar exploration and our contribution for humans going back to the moon. And that's going to be a pretty major achievement, hopefully sometime in the next few years. Tonight we've got a very impressive range of speakers who are going to impart some of their wisdom and their experience in the Australian space industry. And they're going to talk about technologies and engineering challenges that they face in the very, very harsh environments that the lunar environment presents. And they're also going to talk a bit about opportunities for both engineering and companies and researchers in the space market. So I'm very confident that we're going to have a good session tonight. What we're going to do, we're going to have some guest speakers come up, do a bit of a presentation. Then we're going to have a bit of a panel session where we've got some sort of pre-prepared questions. Then we'll do a bit of a Q&A off the floor and also for those online. For those online, your questions are coming through to Pete, who will jump up out of his chair and ask them. For those that in here that want to ask a question, if you could just please, we don't have a roving mic that can head up the back, but if you could please come down, just assemble along the side here and we'll take your questions and the panel can answer them. All right, so strap yourself in. Let's get the evening underway. Right. Our first speaker, all right, is Mr. Enrico Palermo. So I'd like to welcome Enrico to the stage. Enrico has led the Australian Space Agency since January 2021. Under his leadership, Australia secured an agreement with NASA for an Australia-designed, built and operated lunar rover, and issued the nation's first launch permits and facility licences and supported Australia's first commercial space flights. Before joining the agency, Enrico spent 14 years at Virgin Galactic. I'm sure he's got some good stories to tell about that, and including Chief Operating Officer in that business. Originally from Perth, he holds degrees in Mech-Eng, Physics, Applied Mathematics from the University of Western Australia and studied in the International Space University in Strasbourg. So please join me in welcoming Enrico.
Thanks a lot, Mark, and good evening, everyone here and online. It's wonderful to be here and wonderful to see such a turnout. Thank you so much to Andy Thomas and the university for bringing us together in this summer series. We're proud to have partnered on multiple occasions with Andy Thomas Space Foundation. That organisation does wonders in engaging with youth around the nation, not just youth but teachers, and enabling those teachers to deliver the STEM education we need in the nation. Let me too acknowledge that we meet on the traditional land of the Kaurna people, and I pay my respects to elders past and present. And for those that don't know too much about our agency, we really recognise Australia's enduring connection to Sky Country through First Nations people in our logo, and that's something our team is proud to wear every day. Speaking of team, we've got a few in the room, and I must say I'm privileged and proud to lead a wonderful team. We are the nation's space agency. We were founded in 2018, headquartered here in Adelaide at the Lot 14 precinct as one of the anchor tenants. And we were established with a purpose to transform and grow Australia's space sector. Why is that important? It's because the space capabilities we need every day for our prosperity, for our security, and for our economy. And so we do that, we lift the economy, and we do it through 5 functions through government, and I'll go through that, but ultimately it's about improving lives here in Australia. The first is coordination. So if you think about space, whether it's GPS and logistics, imagery, communications, security, there isn't many portfolios or government agencies that in one way or another don't interface with space or buy space capabilities. So one of the core functions and what we're set up to do is to lead coordination of policy across government, and that includes with our states and territories. The second is about building capability, and what capabilities are probably a jargon term in government, but ultimately what can we build, what can we design, what we can operate, what can we use here in Australia for our needs? And so we provide guidance to the sector on where those market opportunities, where is Australia's advantages, competitive and comparative. And through Australian government funding and grant programs, we've invested in more than 80 projects around the nation. And I think when we look back, the results have been quite profound. We've installed infrastructure that allows us to operate satellites, operate vehicles on the moon. I'll talk about that during the panel, through to testing facilities, for example, for radiation hardening for lunar missions. We've seen Australian satellites, Aussie designed, built satellites, be on orbit for multiple years now off these grant programs. And many other things have spun out of these programs. And a flagship, which Ben will talk about, is obviously our lunar rover in Roo-ver, and I won't steal Ben's thunder there. So a lot of work in building capability for the nation where we need it. The third function talks to our international role. Very much the front door to the world's space agencies, whether it's NASA, ESA, or some of our regional partners, such as the Korean New Space Agency. So both bilaterally, multilaterally, how do we advance foreign objectives, but how do we also provide market access? So one of the things our team does is negotiate and develop international arrangements and treaties. And at the moment, we are negotiating a new treaty with Europe, which we see will provide access for Australia's space sector to the $100 billion European market eventually, which is pretty exciting. Our fourth function is to ensure Australia safely and responsibly operates in space, and we do that by administering the Act. We are the regulator for space activities in Australia, so if you want to develop a spaceport or launch your satellite into space, you work with our wonderful regulatory team to get those authorisations. And we've just come off a remarkable year of firsts. We saw Australia's and the world's first ever commercial returns to a commercial spaceport, but not just one, multi-mission returns. We saw our first commercial orbital launch attempt, and we saw Australia's first lunar payload authorised. And so they're all signs of the fantastic work going on in the sector. And the fifth, and by no means the least important, is our job to educate and inspire. We do that through organs such as our Australian Space Discovery Centre at Lot 14, through to celebrating the Australian of the Year now journey on her astronaut program, and to really lean into that message Catherine has delivered. You know, we back ourselves in sport, and we're very proud of that. We need to back ourselves in STEM, and I think that's an important message that Catherine's getting out there. So there are functions in the last 6 to 7 years since the agency was formed. The sector has grown rapidly. If you look at the indicators from revenue to employment, to R&D investment, they're all double-digit, if not higher, percentage increases over that period. We've seen private investment in 2024 reach $300 million annually, and this year will probably exceed that if you saw the Gilmore investment just a few weeks ago, including an investment from the National Reconstruction Fund. The rate of demand for our regulatory function is doubling year on year. We've got multiple Australian companies that have capability and have demonstrated and designed and built and now operate their satellites on orbit. And our spaceflight ecosystem is moving from one-offs. We've had 3 VADA returns here into South Australia with Southern Launch in 12 months. And so we're moving again, one-offs to actually a repeatable business, repeatable ecosystem. And then finally, I think as another indicator of the world wanting to partner with us was the record-breaking International Astronautical Congress hosted in Sydney in October. The world came out in force to see how they can partner with Australia, but also to see how the nation has changed in space over the last decade or so. So just briefly to reflect on the topic today, our lunar journey. It's clear Australia is probably best known because of one movie for what we did for Apollo with the dish. And that is something we celebrate, and the team, and I've seen the team many times out at Tyndall and other locations, are remarkable. This has made us a reliable partner. It's built so much goodwill with our international partners, and that will continue into this new phase of Artemis. But Artemis is different, and it's different in a few ways. And that's something I think we're going to explore well on the panel. One is Australia was a founding signatory to the Artemis Accords. Sounds very legalistic, but this is a set of practical principles to guide the safe, transparent, sustainable civil space exploration of the moon and beyond. So we were one of the first 8. There's now 61 countries, so a 7-fold increase since Australia signed up. The other part that's different, and as I said, something, my call to action for all of you is to take away from today, is what Australia can contribute to Artemis and beyond is much more sophisticated. I'm not saying deep space communications is not sophisticated, it certainly is. But the expertise we have, the opportunity is broad in terms of the diversity of things we can take, but there's also depth if you look at the tech stack and what Fleet is doing with, for example, the Spider mission. So I'm pretty excited. This is the Artemis generation, and if we can only emulate part of what Apollo did to inspire a generation, to drive investment, to have spin-offs to improve life here on Earth, I think the next few years are going to be pretty exciting. So thanks for being here tonight. Looking forward to the discussion.
Thanks, Enrico. And is it really true, did they play cricket on the dish? Have you seen the movie?
Kerry's in the audience.
Oh, okay.
I'll tell you our story.
No worries.
I played cricket on the spy dish up at the rugby.
Okay, so it's a real thing. Our next guest speaker is Dr. Shannon Walker. Now, I did ask for permission just to call her Shannon, and she said that's fine. Shannon holds a bachelor's, master's and doctoral degrees in physics and space physics from Rice University. Before becoming a NASA astronaut in 2004, she worked in mission control at Johnson Space Centre. She flew to the International Space Station not once, but twice. Very brave woman. She was up the first time on the Russian Soyuz, which I can imagine that must have been an interesting trip. And again in 2020 on SpaceX Crew 1, spending 167 days on her second voyage and 163 on her first. So she's spent a fair bit of time in space. Serving as the Space Station Commander during Expedition 65. Shannon most recently served as Deputy Chief of NASA Astronaut Office before retiring in 2025. She lives in Houston with her husband, Adelaide-born astronaut Andy Thomas. Please welcome Shannon.
Thank you. It is great to be here. I always appreciate talking to folks in Australia. I was asked to talk some about what is the Artemis program. We've used that term a lot tonight, and so I just wanted to go back to the basics. Very simply, what is Artemis? Artemis is NASA's term for their current, I have to remember I'm retired now, their current lunar program. And so for Apollo, the main goal was setting foot on another celestial object. We wanted to get to the moon and get humans to the moon. For Artemis, the goal is to be living and working on another world. So for more than 25 years, astronauts have been living and working in low Earth orbit aboard the International Space Station. And so the Artemis missions are to return the humans to the moon and eventually establish a long-term, sustainable human presence on the moon, and to help prepare NASA, the world, whoever's going with us, to send astronauts to Mars. Why do we do this? We do it for the scientific discovery. We do it for technological advancement. We do it for the economic opportunity and growth, as Enrico has talked some about. And we do it for the inspiration of the next generation of explorers. And people should not discount what we do in space, the inspiration it can have for kids and students, and seeing what is possible. In fact, I know that when Andy had his first flight in space, the number of students that were enrolled in engineering at Adelaide University of Adelaide at that time, went up by a huge amount. So it's important. So what scientific discoveries? Well, we don't know yet, but our moon is pretty much a 4.5 billion year old time capsule, preserved in the cold vacuum of space. So we're going to go there and learn more about the moon, how it was formed. That'll help inform us about our solar system, our place in the solar system, and help us understand our universe. So just science for the basis of science. The other thing we're looking to do during Artemis is that we know that the permanently shadowed spots on the moon probably contain ice and other minerals, and these are very important for resources for future explorers. So that's what we're trying to accomplish when we go to the moon this time. How are we doing it? We're doing it differently. During Apollo, it was a NASA-led, NASA-driven, US government paid for trips to the moon. Now we're doing it in collaboration with our international partners and collaborations with private companies. So the private companies that NASA employed before have different roles now than they did during Apollo. And we are focusing on this time, so during Apollo, we had 6 missions that landed on the surface of the moon. They were all in the equatorial plane, essentially. We're trying to go to the South Pole of the moon. Why the South Pole? Where we believe that's where most of the resources are. So it's a much more complicated program that they're trying to enact now. The other thing we want to do is increase the surface exploration durations. When the Apollo astronauts were on the moon, they weren't there for very long. Our initial flights to the moon will have people living or working on the surface for Artemis 2 should be at least for about a week, and then they'll get longer for there. So we want to have people living there for longer periods of time to give us expertise. We know how to live off the planet. We do it on the space station. We've been doing it for 25 years, but we want to be able to do it farther and farther away from planet Earth. So that is Artemis. So let's go to the next slide. And where are we now? Artemis 1. Artemis 1 has been accomplished already. And I do want to point out this is not an AI-generated image. This is an actual image from Artemis 1. Artemis 1 flew in 2022. It lasted for 25 days. It was an uncrewed mission, so there was no crew on board, but it was designed to test the rocket, the capsule, the landing and splashdown systems, the recovery of the capsule. So just getting our feet wet again and really stressing the vehicle, the Orion capsule there that you see in that picture, of stressing it so we know its limitations and it's ready to go when we actually send people. So this was taken there was a camera on one of the solar arrays, and so when it was the farthest it was away from the moon, we pointed the camera back and got the moon and the Earth. So I don't know, that picture kind of gives me chills to see that. I think it rivals the Earthrise picture that was taken during Apollo. All right, Artemis 2, let's go to the next slide. Artemis 2, people. This will be our first opportunity to send a crew back to the moon. It is not going to land on the moon, it's going to orbit around the moon. That's the crew there, starting on the right, that's Christina Cook. She's a mission specialist on this flight. Reed Wiseman is the commander. Victor Glover, whom I flew with 6 months on the space station on my last flight, and so now he's going to the moon, and I retired. I'm not sure I like that mix, but okay. And then that's Canadian astronaut Jeremy Hansen. So it is an international mission that we are taking to the moon. What are they doing? They are going to launch. They're going to do a big orbit around the moon. It's going to be about a 10-day mission. They're going to be testing the life support. We didn't have life support on the first one because we didn't have any lives that needed to be supported. We did do science on the first Artemis mission. We're doing more now, but we really want to make sure that the capsule can support this crew. So they're actually going to orbit the Earth a few times before we actually send them off to the moon. We want to make sure everything's good. We're going to test the navigation capabilities. Victor's going to fly manual flying of the Artemis capsule, or the Orion capsule, to make sure we understand its handling quality, so we really know what it's all about, and then we'll test our communication systems. And communication is hugely important, and so we're always improving on those, and so we want to make sure those two are good to go when we have our more complicated missions. Now, Artemis 2 is so close to launching. This week, they were doing some of the final testing down at KSC. They have the Artemis rocket on the launch pad. They were doing what is called a wet dress rehearsal, which is where they go through the final stages, loading all the propellant onto the rocket. They don't have crew involved, but they do all the countdown as far as they can go to make sure everything's okay. Like so many testing scenarios, they found a few things. hydrogen. It's a very small molecule and it likes to leak out of things very easily. And so they have some hydrogen leaks that they're going to try and fix. We were hoping that they would actually be launching this Saturday. They haven't set the launch date yet because they're trying to fix the hydrogen leak. But probably early March, maybe into February, we'll just see. But it is so close to having this launch. So that is really, really exciting. Next slide, Artemis 3. All right, this is an artist's conception. We do not have people on the moon right now. And that is an artist's conception of a lander. So Artemis 3 is also to send a crew of 4 up, and then we're going to send 2 crew members down to the surface of the moon on a lander. We've got 2 companies, they've got 2 companies building landers for the moon. You've got SpaceX and you've got Blue Origin. I'm not sure the final decision has been made at this time. Was going to be SpaceX, but then new administrations, new administrator at NASA, things may be a little bit different. So it remains to be seen which lander is going to go first, but we're going to have a lander go down to the moon. We're going to have new spacesuits. I know you probably hear about the spacewalks that are going on at the International Space Station. That is a misnomer. There is no walking involved. You cannot walk in those spacesuits. And so we need spacesuits that have much more flexibility so you can walk around on the moon, so you can bend down and pick up those lunar samples that you need. And so those are in development right now. And the other thing we need is spacesuits that fit a wider range of people. The spacesuits that we have in use on the space station were developed for people that are taller than I am, longer wingspan than I have, and so all astronauts are not 6-foot males that can swing from the trees. So we need spacesuits that fit a wider range, because in the future, even if NASA's astronaut corps is this range of people that are going to the moon, in the future it's going to be this range of people, and so we need that suit capability. And so working with the contractor Axiom Space to build the new suits, and then they will have that technology to build suits for the future. Artemis 3 is expected to be a 30-day mission, so a little bit longer than Artemis 2. 2 astronauts, as I said, will be spending a week on the surface. They'll be testing their systems. They'll be conducting scientific experiments and collecting lunar samples. There might be a rover involved. We'll hear about that later. And then they'll go back up, off, rejoin the 2 crew that will be orbiting the moon, and then head back to the Earth. After Artemis 3, Artemis 4, Artemis 5, the future, those are a little bit farther out. It wouldn't surprise me if there's some shuffling in the priorities or what gets done on Artemis 4 and 5. To be honest, Congress has to decide what they want, and then NASA will implement it, because NASA doesn't get to do anything that Congress doesn't tell NASA to do. And so once they sort out whatever budget they're going to give NASA, we'll know what's going to be going on in the future. All right, let's go to the last one. Enrico mentioned the Artemis Accords. I also wanted to mention the Artemis Accords. It is, I think, hugely important. It's very different from Apollo. We really want to have this common set of principles for cooperation in civil exploration. It's for the peaceful exploration of space, and the other big point on Artemis Accords is transparency. The signatory nations should conduct their operations in a transparent way, and this includes sharing scientific information with the public and with the international scientific community. So everything that is discovered and studied on the moon will be available to the whole world. This truly is to benefit all of humanity. As Enrico said, currently at 61 countries. The last 2 countries signed up just this January, so it is still more countries are joining in the Artemis voyage. And so that is all I want to say. Thank you.
Thank you, Shannon. Our next speaker is Ben Sorensen. Ben is the director of the Roo-ver mission and ELO2 consortium, leading Australia's industry research government collaboration to deliver Australia's mission to the moon. Supported by the Australian Space Agency, the mission will see an Australian designed and built rover operate on the lunar surface later this decade, and while advancing national capabilities in cyber, security, AI, machine learning, robotics and autonomous systems. Ben has held leadership roles across the public and private sectors, including board member of the Cybersecurity CRC and commercial director at CSIRO's Data 61, where he led the major collaborations in defence and national security. In 2021, he and his team received the Eureka Prize for Safeguarding Australia. Please welcome Ben.
But I'm not an astronaut, so whatever. Just get my notes.
I'll still take a picture.
Yeah. Okay. That's the story. We're going to the moon. Australia is going to the moon. Good evening, everyone. You know who I am. And I have the wonderful privilege to partner with the Australian Space Agency and lead Australia's national mission to build Roo-ver and operate it on the moon later this decade. I'd like to thank the Andy Thomas Space Foundation for the opportunity to introduce Roo-ver to all of you here and everyone who's watching online, and share what we're doing on behalf of all Australians. Later this decade, a small semi-autonomous lunar rover emblazoned with the Australian flag is going to drive off of a lander onto the south pole of the moon. It's going to look a lot like that model over there that you can see. We call that Bubbles because it looks like champagne. It's the same size and dimensions with a mass of only around 20 kilograms, so a small child. It'll have been designed, built, and tested here in Australia by Australians, and it's going to be remotely operated on the moon from an Australian remote operations centre. There'll actually be more than one of those. And we're all going to be glued to our screens, watching with pride as it happens. The Commonwealth Government, via the Australian Space Agency, has awarded the ELO2 consortium the task of undertaking this mission on behalf of Australia. Space is a team sport. So there's no single organisation in Australia that can do this on their own. And they don't have the capability to do it on their own. So Enrico mentioned the word capability before as a bit of a buzzword. And yeah, I use it all the time too. So everyone knows what it is. It's know-how and can do. It's as simple as that. But it takes time to develop that know-how, and it takes time to build the skills and experience to do the can do. And this program is about doing that sort of stuff. So ELO2 is led by EP Oceania. We're a company that's based in Queensland, and Lunar Outpost Oceania, who's our technical lead. We bring together 21 orgs all together, including 10 universities, industry partners and non-profits. The team I'm privileged to lead includes some of Australia's finest talent, bringing capabilities from across the country to help us succeed in the mission for Australia. So Roo-ver will elevate Australia's capability. Australia has a long history of supporting international space activities since the start of the space race, so we know a bit about that. We've always supported the United States missions and other countries around the world, and the first images from the Apollo program came back through Australia in 1969. We operate a third of the deep space network, along with the US and Spain, and our infrastructure enables space missions around Earth, exploration beyond the solar system nowadays, and returns of spacecraft into ranges here in South Australia. Roo-ver will take Australian designed and made technology into a new domain, to a place on the moon that no humans have been before. No one's been to the South Pole, and it's going to demonstrate Australia's world-leading capabilities in robotics and remote operations. Its journey to the moon will be the longest journey taken by an Australian. Roo-ver will travel over 384,000 kilometres away from home into an extreme and unforgiving space and lunar environment. Nothing about space is hospitable to humans or our machines, and our team are working to apply their specialist skills and expertise to design, build and assure that Roo-ver can survive and thrive in space on the way there and on the lunar surface itself. Space is unforgiving, so we need to deal with thermal extremes, vacuum conditions, high radiation, abrasive and electrostatically charged lunar regolith dust, communications and control at extreme distances, and a terrain that's difficult to predict and navigate, especially when you're so far away from operators and any help. You can't call roadside assistance up there. But why the South Pole? Well, we've heard a little bit about that, actually, and no one's ever been there yet, but it's really interesting to the Artemis program for all the reasons that Shannon explained. It presents the opportunity to support human life on the moon. Geologically, the surface is one of the oldest parts of the solar system. I had 3.5 billion years, but I will take your number. It's at least 3.5. I'm pretty sure it's 4.5. It's billion years old, and it's really stable compared to other parts. So most of the pulverizing impacts cratering the moon have hit on the near side and the far side, and less on the poles. Some of these craters are huge. What you can see here is a map of the South Pole, and I've circled one area. Malapert Mons, just to the side of the crater Malapert. Malapert itself is about 2 kilometres deep, so that's higher than Kosciuszko actually when you put it all together. So they're hundreds of kilometres wide, some of these, and there is another. I haven't got the other site circled on there, but it's just a little bit closer to the pole. Like on Earth, the sun hits at an angle, and so much of the South Pole consists of those permanently shadowed regions that Shannon mentioned. And we know from the Lunar Reconnaissance Orbiter and other exploration, contain water ice. There's also ammonia, there's methane and other compounds there. And these are compounds that we might sustainably harvest to support human life there, providing the hydrogen, the oxygen, nitrogen and other chemicals that can provide the basis for atmosphere and the basis for rocket fuel for us to produce on the moon so we don't have to carry everything up there, and we can use the moon as a base to further explore into the solar system and beyond. Stand by, almost there. So what's the job of Roo-ver? So we're going to be doing lunar operations on the South Pole of the moon. Specifically, we've got 2 objectives. The first is to demonstrate Australia's foundational services capabilities on the moon. Foundational services are the technical capabilities that are the building blocks required to establish and maintain that human presence on the moon. It includes robotics, autonomous operations, computer vision systems, power generation and management, artificial intelligence, navigation, and mapping. It also includes the design of components that are suitable for operation on the moon. And these are all things that Australia already does well on an international scale here on Earth. So we'll be demonstrating Australia's expertise at that extreme environment robotics using those things. The second thing we'll do is carry a NASA payload, and Roo-ver is essential to the technology demonstration of that payload. What I can't do is go into details on that payload yet, but we're really hoping that it's going to help us understand more about the lunar environment at the South Pole. And it's a real privilege for us to partner with NASA as a country and as a team to facilitate that technology demonstration. Roo-ver is going to be carried on the NASA CT4 mission. So we've got a mission designated, which is fantastic. We did a lot of work last year to make sure that we could secure that. And it's going to launch later this decade. We're just waiting for NASA to confirm which of those companies they've chosen to actually carry Roo-ver and other payloads to the moon. So we're expecting to find out pretty soon. Oops. Press the wrong button. There we go. But there's a lot to do in the meantime. So we've got a few years to go yet, a few years of development and testing, assuring that we can do the job and assure that Roo-ver can do the job, to train people. We've got plenty of work to do in the meantime. But Roo-ver is going to carry 5 of the 7 critical technologies in the national interest. And those are capitalised words from the Department of Industry. They're essential to Australia's future productivity and competitiveness as a nation. And all of the intellectual property that we're producing on this here in Australia is going to stay in Australia for the benefit of Australians. So it's important to have these things here, and important to do this work, to build the space industry here and to create jobs and the companies of the future. We also do a lot of outreach like this, and we love doing this stuff, and part of our job is to help inspire Australians. We have 3 lines of effort. One's the technical, one's the communications and outreach, and the other part is industry development. The thing that I'm personally most excited by is the new school curriculum that we're developing with our partners, Victorian Space Science Education Centre, and that's going to go to about 20,000 teachers across the country over the next few years. What that is going to do is bring Roo-ver, space robotics, the moon and space science to tens of thousands of kids across the country. It's going to help develop their passion for it, develop their capability and capacity, unlock their creativity, and inspire our next generation. Roo-ver is about going to the moon. It's about doing the hard tech work of a literal moonshot, but at the core it's about people, and it's about building that capability and capacity of our people. And as Enrico says, the Roo-ver journey for Australia, it's as important as actually getting to the moon. So once again, it's my privilege to be in the position to do this work and to talk to you tonight and to lead the team. So thanks, Enrico, for choosing us, and thanks very much for listening tonight.
Thank you very much, Ben. And I love the last slide. It's all about people, because we say that all the time at Nova as well. If I can just ask our speakers just to assemble at the front here, and they're going to be joined by William Foster Hall. I'll just quickly run through Will's bio. William is a research associate at Adelaide Uni. He leads the university's research contributions to the Roo-ver mission. His work focuses on lunar and asteroid environments, robotic simulation and hardware development. He holds a double degree in mechatronic engineering and mathematical and computer sciences, and is completing a PhD in soft robotics for space applications. William is a Fellow of the Royal Astronomical Society, a graduate of the International Space University, and previously served as a visiting researcher at NASA's Jet Propulsion Laboratory. So please welcome William with our other guest speakers for the panel session. Can you hear me? Good? Good. Excellent. I'm going to ask an unscripted question first. What are the resources at the south pole of the moon? What are we after?
Got to be water at the top of the list, I would think.
We're not going to the moon to find water, though, are we?
Believe it or not, water can, as Ben said, is rocket fuel. So you combine hydrogen and oxygen, you split it, and you recombine it, you can get those engines lit.
Oh, and I thought it was going to be gold or uranium or something. Yeah, amazing. Thank you. Enrico, the first one for you. Beyond the Roo-ver and Artemis, what are other Australian-led or Australian-supported lunar initiatives do you think the public should know about?
Yeah, there's a long list, and back to my point about the increase in our sophistication, our contribution. I won't try to talk too long on this one, but some of that work's happening here in Adelaide. One I think the community definitely should know about, and I think I saw Professor Mortimer out there somewhere earlier, but is the Centre of Excellence, the ARC Centre of Excellence in Plants for Space. There's going to be 3 experiments that go to the surface of the moon as part of Artemis 3, one of those being co-developed by that Centre of Excellence, which has its main hub here and has other universities. So they're looking at, and maybe there are other species, with species like duckweed, a little leafy thing that grows on ponds. How can you synthesize proteins? How can you synthesize medicine? How can you synthesize plastic in an environment that's scarce of water and other things? So fundamental research and science happening in Australia. We're going to be contributing that, and that's going to have spin backs to water scarcity and food production here on Earth, which I think is wonderful. Other initiatives, we're proud to have invested through our grant programs in seeing Australian contribution to missions. So one of the CLIPS contenders, the Commercial Lunar Lander program, is a company called Intuitive Machines. On an upcoming mission, they will have Australian company Advanced Navigation have their quantum inertial navigation. So the navigation system used for the lander is being developed and tested here in Australia. So these are a couple of wonderful examples. We have a facility in WA called SPARK. It's a long acronym, I won't try to recite it, but this was a co-investment by the Australian government through the agency, FUGRO and the WA government. It's an operations centre that's in the Telstra Exchange building, and I'm from Perth, so I'm very proud. We've got a centre that is doing deep sea inspections of pipelines, all the way to deep sea operations lunar landers in one facility. And the reason I bring that up is one of the things Australia will contribute, and Ben covered this well, is our expertise in remote operations, in resource utilisation in situ. So how do we bring a paradigm shift of how we operate mines in the Pilbara of WA to how we operate rovers and human settlements? I think is something Australia will contribute. So there are a few, I could give more, but there's some I'd recommend the audience look into.
Great, thanks. Ben, you're up next. What are the key goals of the Roo-ver mission, and how does it fit into the broader Artemis architecture?
I think I covered a good chunk of that. So we've got two big objectives on the surface operations, which is to undertake that technology demonstration of the foundational services lunar rover capabilities of Australia and that remote operation capability at extreme distances. And the second secondary objective is that technology demonstration of the NASA capability that we'll be carrying as a payload. Overarching for our programmatic approach to it, there's three lines of effort. So there's that technical design, build, test, and remotely operate on the moon. Like, none of that is trivial, none of it at all. So personally, I think that's a great technical goal to do that, but I think one of the goals that I have on that stuff is demonstrating how Australia can undertake industry research collaboration successfully to bring the best of the different sectors together to deliver something which is on a nation scale. The communications and outreach part of us, the goals there are to really inspire and engage Australians in this, to build STEM pathways and to help connect up those people that are younger into these future opportunities as we go through. So we're creating internships, there's PhD students studying here, there's across 9 other universities as well. Main game at the end of the day for Australia is industry development. So we're funded through the grant, through the Australian Space Agency from the Department of Industry. So this is about how do we, at the end of the day, through programs like this, support the development of the industry, stimulate new investment, demonstrate and de-risk it so that the next group that comes along can do an even better job.
Thanks, Ben. Shannon, what do you think is Australia's involvement in the Artemis mean for our long-term role in human space exploration?
I think the involvement that Australia has now is sort of a paradigm shift in Australia. They have been supporting NASA for years, as was mentioned with the Deep Space Network and the lovely dish. But now Australia is much more of an active participant. They're contributing rovers and science. The plant science people are going to have an experiment on the moon, and it's a way that Australia is going to be involved in the great voyages of exploration of this century. And so it means a lot, I think. And I think also, it's been mentioned with the space economy that's being developed here, and Australia having an astronaut program now, which they've never had before, well positioned to be a long-term partner in space exploration.
Great, that's great to hear. William, over to you. Designing for the moon is a notoriously difficult environment, as we have heard about it a little bit today. How is Adelaide Uni contributing to the Roo-ver mission, and what are some of the most significant challenges, apart from weeds that keep popping up, is your team tackling?
Yeah, good question. So here at the university, we're very involved in the testing aspects of the rover. So we've got sort of three key deliverables or work packages that we're contributing to the consortium in general, and those are component level testing. So if anyone's going on the tour, you'll go over to our labs and see our vacuum chambers. So doing a lot of sort of trying to emulate what the temperatures and the pressures are like on the lunar surface. The other big one is mobility testing. So we're looking at one of our other facilities that, again, we're dealing with some weeds at the moment. We're looking at how the two big factors of the lunar condition, which are gravity and regolith, how they influence mobility across when you're trying to actually drive a rover. You know, what's really going on between the wheel and the regolith? How does gravity get involved? It's a really large sort of research question. It's something we're actively working on as part of the research towards this contribution. And then the final one is the concept of operations. So this is basically like a dress rehearsal, which is also, we're going to be running it down at our Roseworthy campus. And it's a dress rehearsal of the mission. So we come down, the folks from Lunar Outpost are going to bring the rover down, and then we're going to play out the mission, go through, see what happens, test all of the sort of key functionality, autonomy, telemetry, communications, all that kind of thing. Those are our sort of our key involvements.
Great, thanks. And those weeds, you told me how you get them out.
Yeah, so big thank you to the Adelaide Rover team. We have a barbecue, and then you can have your lunch once you've done your certain part of de-weeding. Seems to work. Works quite well, yep.
Be careful what you sign up for when you sign up to be in William's team. Enrico, we've heard a lot about, obviously in the past from previous space missions, about how technologies have come out of there like GPS and lots of different things that we use every day on our phones and everything else. What Australian space technology developments do you see benefiting humanity and our planet, extending beyond exploration?
Yeah, I mean, I think we've hit on a few. I've covered the science and the outcomes that will come from plants for space. That will be pretty profound. I think Ben covered some of the architecture of Roo-ver and advancing technologies in computer vision and AI navigation. They're going to have spin-backs here on Earth. So the advanced navigation example I covered, that is directly relevant to navigation underground in mines here on Earth. So exploration on Earth. Another initiative, back to the early question, and to tie to that I think is worth mentioning, so Adelaide-based Fleet Space Technologies, many in the room may know, are going to the moon as well in partnership with the agency. So this is where I see spin out and spin back both ways. So several years ago, we partnered with Fleet to develop a geo, they call it a geode. So think of it as a microphone that listens to sounds in the ground, waves crashing, earthquakes, that Earth's very noisy. And they've been able to really revolutionise how we look for minerals here on Earth. And it's seen them become Australia's fastest growing company in 2023. And they're doing wonders. We are now working with them to miniaturise that geode for the moon, and it's called SPIDER. So we think Australia is going to play a role in finding that ice, but also the other minerals, to your point earlier, Mark, that's on the moon. And Fleet expect to use all the development of miniaturising SPIDER to further enhance their product here on Earth. So there's sort of this virtuous cycle that has been through the history of space, from the camera on your iPhone to firefighting, retardant materials to water purification. I think that innovation will continue.
Great, thanks. Ben, how are robotics, remote operations and advanced manufacturing shaping Australia's lunar capabilities?
In lots of ways. Firstly, I want to acknowledge Adelaide University, like great partner. We love working with Adelaide and key part of the team. What you'll see later throughout the last 3 years has been fundamental to the development of the lunar robotics that we're creating there. So how's it helping the economy? Is that was the question?
Yeah, how are robotics, remote ops and advanced manufacturing shaping Australia's lunar capabilities? So I guess it's reflecting on the industry and how it's actually contributing towards what we're doing in this lunar space.
So Australia is already an expert and leader in extreme environment robotics. We've got this massive land mass. We have remotely operated mining vehicles that are operated from thousands of kilometres away, and operation centres in cities and mining centres miles away. Robotics in defence. EPE, we're a defence company. We have the largest fleet, I think, of field robotics that we work with defence on and other places. They're fundamental to Australia's economy at the moment, and it's only going to grow. Robotics is essential to remove humans from harm's way and to enable humans generally to progress in environments that are harmful to them, so where we can't put people. So the advanced manufacturing side of this is also essential. We need novel materials. We need materials that are capable of operating in those extreme environments, withstanding the very extreme nature of those environments, the radiation, the dust and other things. So there's all these important things about those technologies that enable us on the moon that are applicable here on Earth as well. And I just want to add a bit, something I was thinking about recently. Like at the moment, we do research here to go to space, but in future, and it won't be that far away, we'll be doing the research in space. A lot more of it, we already do it on ISS and other places. There'll be so much more of that research done elsewhere to improve life here on Earth. And that's the switch over time as we start to have that sustainable presence on the moon. Robotics is fundamental to that because we can't put people everywhere.
Thanks. Shannon, how important are international relationships, apart from you and your husbands? And where do you see the greatest potential for collaboration?
Yeah, I think, well, there's the cynical answer that international relationships are important for political support, for continued political support. But really beyond that, these international partners give you access to so much more technology and science development. The investment made by one country is multiplied by the investments made by all the other countries. And as we said, the science for what we're doing at Artemis is going to be available to everybody. And so Australia will benefit, the world will benefit by these collaborations that we do. I think the types of collaborations are the ones that have been mentioned. It's in mining, the remote operations. We're definitely going to be doing mining on the moon, and it'll be done remotely probably for a good bit of it. You guys probably have a lot of expertise in telemedicine that will be useful in the future. The plant science that's being done, growing plants in contained environments is going to be very important to have a sustained presence on the moon. I think also one thing that hasn't been talked about much is Australia's got a long history in Antarctic exploration, and so they've got, the country has experience in supporting remote missions in harsh environments. And so there's a whole bunch that Australia has to offer in collaboration in this with Artemis.
Great, thanks. William, a couple for you actually. First one I had is, how do you actually get the temperatures down to the ranges that I think Ben had in his slide of minus 120 degrees Celsius?
Sure, so that's a good question, because I did like half my PhD in that and just trying to get those temperatures down. So yeah, we've got a while. But yeah, the easiest way is liquid nitrogen. So liquid nitrogen is at minus 196. If you add that to sort of pump it through a metal plate, then that plate will get down to about that, a little bit higher than that, and you get it down to minus like 170. If you control sort of how much nitrogen you're putting in, you can get down to 130 pretty easily in a vacuum, because you don't have heat transfer coming away from that. So that's what we do in that lab. We've got a platen that's cooled with liquid nitrogen pumping, and then it also heats up, and you can go the other way as well with the same plate. Yep.
Awesome. And what advice would you give to young Australians who want to be part of future moon missions?
Yes, that's a very good question. And I think it's interesting because the answer is very different to when I graduated my undergraduate degree. The advice then was pretty much, go do a PhD and then go to America and go work at NASA, and that was sort of it. But certainly in the last like 5 years, we've seen that you don't have to do that anymore. There is industry here in Australia, and you can actually get involved with both, whether it's lunar, or whether it's satellite science, or whatever kind of thing it might be. Those opportunities are available without having to leave the country. It's certainly still good to be able to leave and to go and experience. And I've got students who are in Europe, who are over at Rice University actually. But there's the opportunity to come back now that didn't always used to be, and still be able to do the cool space stuff that we love to do. Yeah.
Oh, that's really cool. And what's roughly the size of your team here at the uni?
So specifically on Roo-ver, we've probably got about 15 people who are involved in various capacities and things we're doing. So we've got 2 PhD students, 3 or 4, 5 academic advisors, and then project manager, Brian. We've got the center management. So there's a lot of people like that. But then, we're a university, so we've got students. We've run a robotics lab with honours students, so we normally get about 30 students in there, and they're all doing sort of lunar robotics or planetary robotics or that kind of thing as well. So sort of difficult where you draw the line, but there's a lot of people involved in different aspects.
Yep. Okay. We might just do one more general question, which maybe all of you might like to have a little crack at, and then we'll go to the online, if there are any online, or if anybody in the audience here tonight wants to come down and ask a question, feel free to sort of make your way down, and we'll get started on that in a minute. The last one I'd just like to throw on the table is, what does a sustainable human presence on the moon really look like, and where might Australia fit into that vision?
I could start with that. I always think it's, when I first heard NASA saying, oh, we're going to have a sustainable presence on the moon, I was like, well, what does that mean? Are we not overfishing the seas? Are we, not using too much water? But really what it comes down to is having the infrastructure in place and having work to do there that we can support continuous or at least long-term presence on the moon. And so it's really building out the facilities there for the work that we want to do. And I think what Australia is going to do, all the things that we've mentioned before, and plus now with an Australian astronaut program, good chance you'll have an Australian astronaut working on the moon.
Will there be cricket on the moon?
I don't know. We'll have golf for sure. I don't know. Good question.
Anybody else want to have a...
We'll be there from the beginning, obviously, because our deep space communications, so we'll be there from day one with NASA and international partners, and remain very proud of that. But I mean, I'm certainly bullish on the opportunity for us to spin in our remote operations, our life sciences expertise. It's really NASA and international partners, the arms are wide open to be part of this, and so it's really our opportunity to grab.
I want to add, I think it's our choice. So, we have these things at the moment, but there's a choice for Australia and Australians, Australian industry. It's not just up to governments to choose what do you want to do. So there is, if you go into the cupboards here, if you go into the cupboards of any university, CSIRO, there is amazing technology that's in there, and there are just amazing people that know how to do some stuff. Point them at the right problems, have the right capital behind them. Australia is a world-class research and innovation nation, and it is a stable place to do these things. It's a great economy, and it's a great place to make things and then take it overseas. So we've got heaps of opportunity. It's just our choice. So obviously, I'm really bullish about this. I think it's doable. We just tend to go along with the flow a little bit more. We could just push harder.
No problem. Thank you. Right. Have we got any online questions? We have an online question. Great.
We have a couple of online questions, and for the audience, I'll ask a couple of these questions, but if you want to come down and line up at this microphone, then you can ask your questions as well. So I've got a couple, which is sort of educational related. I'll tell them both together and see who wants to answer them. But basically, the question is from Timothy. What roles do you see teachers play in Australia's space future? And will there be ways schools can engage in Roo-ver or Artemis missions as they happen? He's saying this is an amazing engagement that the students have. So there's probably a couple of you would probably want to answer that one.
I think teachers' role is one of the most important roles there is, particularly at the younger years. It's shaping young minds and inspiring them and helping them understand what's possible with their lives, pointing the pathways forward. It's a great privilege of mine that I get to take these show models into schools, and particularly my kids' schools. So I'm the best dad in the school for sure, because I bring in the lunar robotics. But over time, I can see them change. Their conversations are different. The conversations around the dinner tables are different. Like at my place, it's how do you deal with the radiation problem or the thermal problem? And it's fascinating. We have a partnership with the Victorian Space Science Education Centre. They're a partner in the ELO2 consortium. They've developed curriculum, and they're continuing to develop curriculum over the next few years, which will roll out. Before we're even on the moon, we will have had thousands of students across the country that have been exposed to that through 10-week programs where they get to engage with lunar robotics, the lunar environment and space in general. And that's going to grow over time. So it's not just in Victoria, it'll go through here in South Australia with Hamilton's Space High School. It'll be in WA. We're talking to other state governments as well so that we can scale this. We do need partners for this because we're funded to do a whole bunch of stuff, but our focus has to be to do that big mission at the front and find these other ways to bring in other partners to help support that. So state governments are a key part of that to enable teachers. And you couldn't talk down the importance of the role of teachers at all.
Absolutely, and this is why the journey is more important than the destination too, right? How do we take the whole nation on this journey of Roo-ver, which we want to be the first step, not the only step. And from the naming competition, we had I think 20,000 votes in the final selection. Many of them were classrooms, so it was thousands of kids that were exposed to Roo-ver right at the beginning in the naming as well.
Got another one, a health-related one. So we've got, sounds like she may be a nurse in emergency registered nurse areas, but that's going to be critical for us in remote operations and space flight, long-term space flight. She sees nursing as an operational infrastructure, not just clinical support as part of these missions. Do you see space nursing become a formal capability within Australia's space ecosystem?
I think yes. I think once we have a long-term presence on the moon or on another planet, we're definitely going to need nursing and medical capability. You can only train astronauts, scientists, and engineers so much, and there's so much more knowledge and capability that comes with the trained medical professionals, especially nurses, that it is going to be an important facet of sustaining people on the moon.
Maybe even sooner commercial LEO destinations once they're operational as well, I think.
That's a good point, yes.
Let's jump to one of our questions from the local audience.
Hello. So my main question is, I'm curious what you think the far future of the moon is. Will there be like moon cities or towns, or will it stay pretty isolated?
Question.
I think the answer to that, I think in the very beginning it's going to be pretty isolated, but I think just as we're seeing the space economy grow here on Earth in different countries, different companies, different capabilities, once that toehold gets put on the moon, then it really will grow, and it'll probably grow fairly exponentially to make however a lunar city turns out to be. I can't tell you that's going to be 50,000 people on the moon, or if it's going to be 200 people on the moon, but I think it's definitely going to grow. It'll start off slow, and it'll start growing really quickly.
I might just hop on that as well. I think like the moon is very interesting in the ways it does line up with Australia. So we spoke earlier about one of the main motivations for going to the moon was mining. And if you draw that sort of parallel, I think the sort of sediments that we see on the moon are going to be like very similar to the settlements we currently see, right in the middle of Australia, right? You've got your FIFO out to Roxby, you've got all your mining infrastructure and supporting for the people doing that work. Outside that work, there's not too much to be done. There's science and there's supporting stuff, but I think it's, primarily that parallel between both, that's, something to look at.
With the possibility of mining or at least extracting valuable minerals from the moon, it has been reported that there are naturally occurring deposits of helium-3 on the moon, which is very valuable. Do you think it's going to be practical, economic to extract that and bring it back to Earth? And or I guess the priority is going to be for life-sustaining minerals first for the people who are going to be working there. Any comments on that?
I think we'll see. It's going to come down, like on Earth, right? The economic business case to extract. But if we have, fully reusable vehicles going to the moon, or if you look what even space is predicting, or even starting to sell to space agencies to deliver tonnage to the surface of Mars, the numbers are going to go down and they're going to be pretty low. So I think over time the economic argument, there's legal and other things we need to think through, and governance, but I think the economics will be driven there by reusability and repeatability, like we've seen with low Earth orbit.
I agree. I think economics is it. That is the word. The scarce resources and how do we access them and deal with them, and getting to there. So if you look at the cost of launch with SpaceX, which is through the repeatable rockets, and how that's come down, that enables many more things that were just not possible a decade ago. And frankly, we weren't really thinking about that stuff a decade ago. Space-based communications is now at a level that we really weren't imagining at all 10 years ago. It's disrupted other plans, billions of dollars of plans that even Australia's had to do stuff. So it's very difficult to imagine all the detail of that stuff, but economics and people finding the economic opportunity and then promoting that and pursuing it, not just because the moon is there, let's travel there, which might have been the challenge in the past. The economic opportunity will drive it more, and people are looking for that. So they'll, I think, tend to find that as well.
Thanks.
Thank you. My question revolves around global collaboration. If I'm correct, my understanding about the attraction of the South Pole is the permanent deep shadows and the opportunities it gives for humans to get away from the heat, amongst others. On the international front, I believe there's already a rover on the South Pole, courtesy of India. Perhaps someone could elaborate on its current status, what it's achieved or not achieved. Is it still viable?
It was a wonderful mission by ISRO. Pragyan, I think was the name. Vikram was the lander, and then I think Pragyan is the rover. And we have a strong partnership with the Indian Space Research Organisation. Most rovers, including Roo-ver, at this stage can only survive the lunar day. So roughly 14 Earth days. I think part of the next iteration has to be power sources and energy storage sources to go longer than a lunar day. So the missions are still relatively short, sort of 2 Earth weeks. Pragyan is not operating anymore so it's very different from the Mars rovers like Spirit and Opportunity and Perseverance. They have solar power constantly and can keep going. So I think all rovers that have gone to the moon so far have only been able to survive 1 lunar day.
So has there been collaboration on results with India They're open about it?
India, if I recall correctly, Israel have actually shared a lot of their scientific findings, I think. I can't recall.
I honestly
yeah, I
don't
don't
know.
know.
I'm sorry, I don't know the status.
We
Yeah,
haven't been using them for Roo-ver, but we do get inspired by what they're doing, that's for sure, and where we've found novel ways that they've approached problems. We've learnt from what they've done, so that's a key part of that collaboration is the sharing of the outcomes, and that's then incorporated because all around the world developments are happening, projects are happening, and that knowledge sharing is happening, and papers are getting written, and then we get the results and we learn from those. So it is evolutionary from a technology perspective and inspirational as well to see other people do great things and think, yeah, we can do that.
Global community effort, thank you.
Hello. I was just looking to know what you guys see or hope to see, like which opportunities would come out past 2030 for someone as young as me. I'm in high school right now. So when I've like graduated uni and stuff, what opportunities do you hope to see in Australia for someone like me?
That links to a question we got here. Is there going to be a Roo-ver 2, a Roo-ver 3? Was another question we had from the
Roo-ver's our flag. So to answer that first, at the moment, Roo-ver is our flagship mission, and success breeds success. But again, journey is more important than destination. So I think it's for government to think about what comes after Roo-ver. But government is investing in space companies through the National Reconstruction Fund, for example, that can also generate commercial demand and commercial interest in other payloads and missions. I mean, it's difficult to predict beyond 2030, except that I think I think they'll be flushed with opportunities this is a global market that's forecast to be well over $1 trillion, maybe up to $1.8 trillion when you look at value add-on applications. And back to Ben's, what we contribute from our tech base, the ingenuity base. We're in many of Australia's first space startups are all roughly celebrating their 10-year birthdays. Fleet, Myriota, they've scaled, and so I think we'll be in the next scaling phase towards the end of this decade of that next generation. So, we can't do everything. We won't do everything in space, but I think the areas we've talked about, but also building on what these companies are already doing.
Yeah, I can't predict exactly, but there are, if you look at those 7 critical technologies in the national interest, if you're interested in engineering or science or any of those things, if you focus on those things, Australia has chosen those and invested in those because it's recognised that they will underpin Australia's future competitive advantage, which is economic. And that will attract investments. And it does attract investment at the moment. The NRF, National Reconstruction Fund, invests in those things. Look, our goal through the program beyond getting onto the moon and running that mission is develop intellectual properties, create assets out of those, build value out of those, translate them into not just the space industry, but agriculture, mining, aged care. We're not sure. I don't joke about aged care. I was talking about it today. Computer vision can be fundamental to enabling, independence of older people in their homes. There's so many pathways that we can't tell where that technology will go, and this is the nature of innovation and the exploratory nature of science, finding where their value is. Plenty of places, but I think anyone that predicts it and says it will just be this will be wrong.
Thank you.
I'll just ask another quick online, then I'll talk to you. What role do you think quantum physics will play in the growing space sector?
It's already playing a role. There's papers I've read. If we're going to have a quantum-enabled internet, as you look at, I'm not an expert here, and there's probably quantum physicists and other experts, but in terms of your protocols, having as part of the global network satellites with the connectivity is pretty important to that. As I said, advanced navigation, have quantum inertial navigation systems, quantum sensing for space, so doing things such as looking below the surface. We have a great company here in Adelaide called Quantex that we're proud to have partnered with. They are preparing their atomic clock for a space mission, and so then you get into very high precision position navigation and timing using quantum physics. So actually I think it's already a key part of what's happening in the space sector, and many of the World Space Agency are invested in quantum-enabled optical communications right now.
Yeah, not just, there's several types of quantum, so I'm not a quantum physicist or scientist in any way, but quantum secured communication is a really important thing. So space communication is already fundamental to our lives. We get to call all of our friends and family around the world using space communication, but post-quantum encryption, which Australia actually is a world leader in with the CSIRO, and there's a bunch of work that's been done here at Adelaide University on that over the years as well. That is something that's growing. Our partner ANU is doing a lot of work on that at the moment with laser-based quantum secure communication. So, yeah.
Excellent. Next to the young lady.
Hi, with the leak with Artemis 2 happening so close to launch, would you say that's a little concerning or pretty standard?
I would say that's actually pretty standard. That's one of the reasons we do, or they do, what's called the wet dress, to go through that and see how everything is operating, if there are any leaks, so that you can repair it and have it safe. And it's always done just before you launch. We do that with every human launch that we do. SpaceX goes through their wet dress. Boeing did the same, and so we're doing it with Artemis. So it's standard procedure, and it's not unexpected to have a few problems crop up. You hope that there's not going to be any, but it's not unexpected at all.
Thanks. It is your turn.
Wow. I've got to say I'm very excited to be sharing this space with all of you people, honoured. The kid in me is excited to be here, in the same room as someone who's been into space, who used to look through the telescope, and all that sort of thing. So as I got older, I'm starting to explore human evolution and psychology and all that, and that's what's really getting my interest up nowadays, now that I've been on this planet for a few years. And my question is probably around this thing that I've heard about, and that's called the overview effect. So it's probably for you, Dr. Shannon Walker, if I got your name right. Yep. So I'd like to know what that's about and how that affects the human race.
Yeah, yes, you have my name right. So the overview effect is a term. It's not something that every astronaut necessarily subscribes to, but it is the feeling that you get when you go into space and look back on Earth for the first time and see how everything is so connected, and it just gives you a different perspective about life on Earth. Some people experience that, some people do not. I think the ones that don't have such a dramatic shift in their perspective are people that already realize the connectedness that we have on Earth. You get certainly a different viewpoint from Earth. You can see the physical things like burning forests and how the smoke goes across the continents and the oceans to the continents on the other side of the world. So you can see how everything is physically connected. But if you have a good understanding that before you launch, you may not have quite the dramatic experience in space.
Have you had that? Oh, sorry. Have you had that experience yourself?
I'm one of the ones that didn't have such a dramatic experience in space. Yeah. So, sorry. It's still really cool to be in space and look at the Earth, but I had a pretty good idea that we all affect each other on the planet.
Right. Thanks very much.
Thanks.
So much. I have one question for Enrico. I think I see that how in the last few years how the space agency has helped the space community here in Australia to grow in a very fast pace. And I would like to ask you one question. Generally, we ask for 10 years, but I think that the Australian Space Agency is moving so fast. I'd ask you, how do you see the Australian space industry and the Australian Space Agency in the next 5 years from now? How do you see how it's going to be? And one question to Shannon, Dr. Shannon, I'd like to know how it was, the difference that you think that it was to fly with 3 different spacecrafts. How do you describe each one of these spacecrafts that you have flown?
I'll go first. I think I'm really interested, very interested in the answer to the second question. Thank you for the question. 5 years from now, so Australia will have a rover that is operated on the moon. That's pretty profound. That'll be the first time we, as a nation, have put something on another celestial body. So that's pretty cool. I'll go back to the leading indicators I covered before. You know, as I said, we saw about $300 million investment in the sector in 2024. We'll see equivalent this year. So if I look at the regulatory demand, we'll have a spaceflight ecosystem here in Australia, both launch but returns, and importantly returns for pharmaceutical science and manufacturing. And you know, Southern Launch have attracted VADA, and there's a lot of other international and domestic partners that want to use Australia's geography for returns and for that science. So I see an evolution of a closed-loop ecosystem here in Australia, which is pretty exciting. I certainly hope we will see many more Australians go to space, but you know, 5 and 10 years into the future, and you know, once we start seeing commercial LEO destinations, that's really going to even further democratise access to space. Yeah, you know, we're only going to see space more and more be pervasive in our lives. So I think one of the things we have to look at in Australia is making sure our access to those technologies, to those critical services are maintained. So do we see Australian constellations for certain critical services develop? I mean, there's sort of, I keep going, there's a lot of different things. I mean, 5 years will go quick, you know, with the space agencies almost eight years old now. But next 5 years will be pretty transformative, and with humans going back to the moon, I think the public consciousness in Australia about space will you know, be at levels it hasn't been before.
All right, space vehicles. So I'm assuming by the 3 vehicles you mean Soyuz, SpaceX, and the space station?
Yeah.
Because those are the 3 I've flown on. So my first flight was on the Soyuz. I spent a lot of time in Russia training with the Russians, had to learn the Russian language. I was trained as a pilot on the Soyuz spacecraft, which was really, really neat to be able to operate the spacecraft. It's an opportunity I honestly didn't have necessarily in the US. I would never have been able to be the pilot on the shuttle because NASA was only using military test pilots. Now with the other vehicles that we're flying to the space station, there are other opportunities. But since I was not a military test pilot, I volunteered to go work with the Russians. So the Soyuz spacecraft is very cozy. I don't know if you've seen pictures on the inside. It holds 3 people. It's like you're all crammed into the front of a Mini Cooper. But it's a really, really slick spacecraft to fly. It's got a lot of capability. It was developed in the 50s, but the Russians keep updating the avionics, and so it's a very, very capable spacecraft. It's got lots of fuel on board, and so it has the ability. When I flew, we took 2 days to catch up to the space station, so I spent 2 days. You've got the capsule where you launch from, and it's really cozy, and then there's this orbital module on top of it, which has cargo space, and so you've got some room to move around in. So 2 days flying up to the space station. But these days they fly up to the space station in 2 orbits, and so about 3 hours after you launch, you're at the space station. So it's an extremely capable vehicle. The SpaceX Dragon is very neat. I was on one of the early flights. I was on the second flight that flew people. At that time, it was a very sleek and very pretty spacecraft, but it wasn't, I would have to say, as nearly as habitable as the Dragon was. And I know the SpaceX Dragon looks big on the inside as compared to the SpaceX, but actually as compared to the Soyuz actually has more internal volume than the SpaceX Dragon does. And one of the things with the Dragon is that it's got a very touchy center of gravity constraints. And so whenever you took something out, all your stuff, your food, your clothes, whatever, are behind panels. And you always are constantly having to open panels, take something out, and then when you're done with it, put it back, because the way to keep the spacecraft flying in the direction and not use too much fuel, you had to manage your center of gravity very, very tightly. You don't have those constraints on the Soyuz, so you have a little more flexibility where you can keep your snacks out and keep your water out for longer periods of time. And so Dragon's gotten better. They actually took our advice. They have more Velcro places so that you can put things different places and it's not all floating around. They actually have foot restraints now on what would be considered the floor, so you are able to stabilize yourself. And so it's just an easier place to spend time now, although it's never going to get to the space station as quickly as a Soyuz can these days. Space station, amazing place. It is a lot bigger than most people think. It is, I don't know how many modules are up there. Each module is about the size of a city bus. And so you've got lots of room to maneuver in. My first flight, we had 6 people up there. My second flight, we had 7 people on the space station. You can be doing whatever work that the ground is asking you to do for the day in a different module from everybody else and never see anybody during the day. And so it was really great at night to get together and have dinner with your crewmates and do like people do at home on the Earth. What did you do today? How was your day? What's going on in your life? And so it's a great place to spend time. It's a little bit more, I won't say crowded, but there's a lot more stuff at the space station now than there is my first flight. And so if you see pictures comparing the space station now, it's got wires going everywhere because we just have so much more going on. But it's a really neat and very comfortable place to live for long periods of time.
Thanks, Dave. We've hit time, but if we can do 2 questions really quickly for the panellists to answer quickly as well.
Right, very quickly. So the access to space has really exponentially increased in the last sort of 5-10 years. And so for the panel, what are you most excited about that we might discover with that increased access over the next sort of, 5 years or so, that you maybe hadn't thought might be possible more recently?
Less about discovery, more about the opportunity of, I think one of the points that Enrico touched on in his answer before was Australian constellations. So increasing access to space, particularly from Australia, we look forward to seeing Gilmore's continued success and other organisations that seek to go down that path, and those that are producing other space vehicles to be launched up there. So I think Australian-based space capabilities and scale of those.
Now, last quick question.
Thanks, Peter. Mark Ryan from Ecospace. More for Enrico. The industrial base in South Australia over the last decade has absolutely blossomed in supporting space as well as nationally. Where are the gaps? What are we missing in our infrastructure architecture at the moment that you'd like to see expand in the next 3 to 5 years?
Yeah, well, wonderful question. And some of it has expanded quickly. I mean, if you asked me that question 5 years ago, there may be still some gaps here, but it would be essentially printed circuit boards and the ability to sort of keep the supply chain here. That has rapidly developed in the last 5 years. Some answer has kind of changed. I think it's now the skill sets around integrated systems. If we're going to develop a large ecosystem here, I think all the supply chain elements are coming together. You look at Gilmore, they have over 100 suppliers around the country. So to AT Space, we've seen Ben's supply chain, but I think the expertise now that we need is building integrated systems, because when you can do that in country, you get a flywheel effect, right? If you look at Rocket Lab, what they've done in New Zealand to spin off, well, they haven't spun off, but Dawn Aerospace, using the supply chain revenues, I think, so for me, it's the system integration that can take the conceptual design task in here as well, like GhostBat has done, I think things like that.
I've got a couple of questions, actually. All right, real quick. For Shannon. What's your favourite movie about space? And is it Gravity, which was produced here in Adelaide by Rising Sun Pictures?
Or let's go with Gravity. No, it's a good, I do like Gravity, a lot of people don't, but I like it. It's really hard to answer what my favorite is. You've got your classics, 2001, you've got your silly movies like Galaxy Quest, they're all entertaining, and you always have to, I'm sure, doctors yell at the TV when, the doctor shows are on, and lawyers are yelling at the TV when the lawyer shows are on, and it's easy to yell at the TV or the movie screen when they're doing silly stuff in space, but if you take them for what they are, there are a lot of good stories, and so I don't really have a particular favorite. But Gravity's good, yeah. It's a nice space disaster movie with some psychological overtones. It's good. Great.
Okay, we might finish it up there. Thank you very much to the panel members, and would you just put your hands together and thank them for a very interesting discussion and lovely presentations. That was really, really interesting. I found that I certainly did learn something, and I hope people here learned something tonight. I'd just like to thank everyone for attending, both those online and those that came out tonight. And for those who put up questions, thank you very much for engaging and sort of coming out there and doing that. Thanks for attending. Hopefully there'll be a big show up at the next one. I'm going to hand over now to Darcy and Mark, who will just close the evening out. Thanks.
Thank you so much, Mark, for that. Yes, big round of applause for Mark. Absolutely. Now, I know some folks in this room have somewhere that they need to rush off to very quickly in terms of a lab tour, but bear with me just a few seconds. You're in this room, you love space, so you'll love a few extra space updates. Quickly, on the lab tours, if you are attending one, you'll just head straight out of these doors, head straight to the left. You'll have some people probably waving you down, and it's not too far to walk, so you'll be there nice and quick. If you are a student from Children's University in the room and you want a stamp for attending tonight, please make your way down over here and we'll do a little stamp for you afterwards, but thank you for coming. Our next Summer Space series will be on the 20th of Feb, and the theme will be Australia's role in exploring and understanding the universe. So make sure that you attend for that one. It'll be a pretty exciting discussion. There is also a Roo-ver roundup coming up on the 11th of Feb, so please make sure you check into that. We will share a link with that when we're sharing the recording of today's session. There's a few incredible artefacts to look at up the front. You've obviously got the Artemis rocket over here, and then you've got Roo-ver, or Bubbles, as it is lovingly called, this one. And then we've also got, William has very proudly brought over some lunar regoliths, so please come and have a look if you've got some time. Also, if you did have questions that weren't answered, feel free to come down and have a chat to any of the panellists. They won't be here for too much longer, but if you would like to have a chat. Also, just very quickly before I thank our incredible expert speakers, the student in the audience that came and asked a wonderful question about future opportunities, could they just put up their hand for 1 second? Over there. No, you've got people pointing at you. I can see you. I just wanted to say a massive thank you for asking that question, because that's an incredible question that a lot of people in this room were probably wanting to ask but didn't have the opportunity to do so. And they're going to hate me for it, but the people who work for the Australian Space Agency, can you put up your hand? You don't have to move, just put up your hand. And I know who you are, so I'm watching all of you. Everyone that you see there has a very different background. How they made it to the Australian Space Agency is very different. You've got people from international relations, media, medicine, engineering, everywhere in between. So there's lots of opportunities. And just to be way more annoying, everyone in the space industry, pop up your hand. Yeah, so there are way more stories that you can come and have a chat to. So if you'd like to have a chat to any of these folks, if it's not tonight, please feel free to reach out to them. Space folks, we love to chat about space. So an amazing question, thank you for asking it. And please do make sure that you reach out if there's anything we can do to support any student in finding their pathway forward. And with that, I would just like to say a huge thank you to these incredible people, Mark included, hiding behind me over here, but Enrico, Ben, who came all the way from Queensland to have this chat, Shannon, who came all the way from America as well, and then also Will, who did come from across the way, but you're about to go and have an incredible look at his lab and see what he's been working on lately. But we're so appreciative to all of these expert speakers for coming along today and sharing their stories with us. So huge round of applause for the team. And with that, we'll let you disperse in your various directions, but you will get a recording of this sent through soon. So thank you so much.
Thanks, Enrico.